Greetings and salutations. Welcome to the EzeeLinux show. This is version 18.17, recorded April the 12th, 2018. I'm Joe Collins, and in this video, we're going to talk about the care and feeding of your SSD. The reason why I'm posting this video is because I'm actually running one these days. A couple of days ago, I mentioned on the EzeeLinux page on Facebook that I had installed an SSD in my main machine, and that I was wondering how long it would take me to fry this particular one. That is because a couple of years ago, I had a couple of SSDs knocking around my network. I had an OCZ and an Intel, and I kind of fried them. I kept reloading them and physically knocking them around, and finally they just gave up the ghost one day and said, I'm done. So it was a big joke there for a while that the only thing I trusted in was spinning rust. You know, in spinning rust we trust, and so that is a reference to that. So those of you who do not know what that was all about, that's what it is. But I decided to go ahead and get a new SSD for my main production machine because I was using a drive in there for the system that is pretty old. It was a 10-year-old Velociraptor by Western Digital. It's a 10,000 RPM drive, and it's very, very fast, but it also happens to have 7 years of uptime. So I thought, why not? It's time to join the 21st century, I suppose. I do tend to lean more toward the spinning drives as far as my trust factor is concerned, but these days that's probably unwarranted on my part because SSDs have improved so much. One of the questions that I get on a regular basis kind of goes like this. Hi, I just installed Linux Mint, Ubuntu, or a child of Ubuntu onto a computer with an SSD. Is there anything I need to do to optimize Linux Mint, Ubuntu, or a child of Ubuntu for that SSD? As of Ubuntu 16.04, the answer is no. Ubuntu figures out that you have an SSD, and it does all of the tweaks and optimizations for you in the background automatically with absolutely no input from the user needed. It's taken care of. For those of you who are maybe brand new to computers and you're not quite sure what we're talking about here and you're just about ready to click off and watch another video, let me explain very quickly what we're talking about. Computers have hard drives in them traditionally, which is a box that has a little platter in it, and that platter is coated with what amounts to rust. It is a magnetically sensitive coating. And then there's a little arm with a magnetic head on the end of it, and as that platter spins under that head, it is moved back and forth across the drive, and magnetic patterns are written onto that disk and then read later. This is how your data is stored. That's a regular hard drive. An SSD is a box full of flash memory, also known as an EEPROM, E-E-P-R-O-M. That is electrically erasable, programmable, read-only memory. And they take a whole bunch of these chips and they cram them together into this little box, and that's how you end up with something that you can either mount in your computer, an SSD, or a thumb drive that you can write your stuff to and then pull it out of the USB slot, or even an SD card. Those are all different examples of an EEPROM. An SSD, unlike your SD card or your USB stick drive, they are designed to run all the time, and they have a lot of advantages over the standard spinning drive. The biggest advantage is speed, because there is no mechanical device. There is no arm with a little head moving across the top of the disk. There's no seek time. There's none of that. SSDs are extremely fast, especially when you're talking about reading. With writing, they're about the same as the best spinning drives, depending on the quality of the SSD that you're using. So there are actual advantages and disadvantages. We're not going to get too far into that in this video. You can go look that up for yourself. Spinning drives are usually good for long-term storage and big data, like if you have a bunch of music files, video files, whatever you happen to be storing on a server, you probably want that on a spinning drive. But if you want speed, you get an SSD. In Linux, a lot of folks, including myself, what they do is they use an SSD for the operating system and then use a very fast spinning drive for all of your data in your home directory. And I'm going to show you how I've got that set up as we roll along in the video. I've put together some basic notes which will be in the description for the video that you can look at or maybe copy and paste and keep for yourself for future reference. When I decided I was going to do this video, I started to do a little bit of research just to do some fact checking for myself, and I found that the internet is still just as packed with outdated, useless information when it comes to solid state drives as it was a couple of years ago when I looked at it before. There's a lot of paranoia out there about write cycles. You're going to hear that people will say that writing constantly to your SSD will destroy it. It is absolutely true that the little EEPROM chips, the little flash memory chips in there, they only have a certain number of writes, but modern SSDs, they do a lot of wear leveling in the background, which means that they're moving data around and trying to make sure that no one particular little EEPROM chip is getting used to the point where it could actually fail. And usually they are packed with extra EEPROM chips that over time, if one does fail, the drive can just basically mark it as dead and go on, and the actual capacity of the drive doesn't change. As a matter of fact, the latest generation of SSD drives, it is said that they can run for 10 years without any problems whatsoever for the average user. And they are extremely reliable these days. So a lot of the digging around in the file system itself and changing different parameters is probably not necessary when comparing them to spinning drives as of 2018. So I'm not even going to get into a whole bunch of that. But we'll talk about a few things that are important to understand. And one of the first mistakes that people make a lot is they go, okay, well, I have a spinning hard drive, and then they go out and they spend a bunch of money and they buy an SSD to replace it, and then they use a utility like the DD command or CloneZilla to transfer all the data block by block from their spinning drive to their SSD. Now, in the process of doing that, you are probably screwing up the partition alignment to where it's not optimized for the SSD itself. And that is because the formats for a spinning drive and an SSD are actually slightly different as to how they are aligned. And essentially you want one cluster of the file system's format to match up with one of those little flash memory EEPROM chips. And so that if you're writing to one cluster, you're writing to one chip. What you can have happen is that if your partition is misaligned, then every time that you go to read or write to the SSD and you're reading or writing one cluster, it has to read from two of the little EEPROM cells. And so therefore, you essentially get two reads and two writes, and that slows the whole drive down. So you want to make sure they're aligned. And the best way to do that is to install the operating system directly to the SSD, back up your data, and then put it back when you're going from hard drives to SSDs. There's also some other tweaks that get done. The operating system itself needs to know that it's on an SSD, so it can make some changes to how it writes to the SSD, particularly the write order, and this is all done at the kernel level. Whether or not the Linux kernel just says, hey, that's an SSD, even if you just move it over, I'm not really sure. There may be some other tweaks going on. So your best bet is to just install to that SSD if you can, and then you know you're just starting off on the right foot and everything will be cool. So there are a couple of user commands that we're going to talk about that go along with SSDs. And yes, I do know that there's a whole bunch of stuff out there about, oh, you need to go and you need to hack on your fstab file and you need to turn off access times and all that other stuff. I really don't think that that's absolutely necessary unless you are running an SSD under a very high input-output situation, maybe in a server. That would be something you'd want to do. For the average desktop or laptop, SSDs these days, with the wear leveling that they have and the quality that's being put out, they will probably be just fine, and they'll probably last longer than a spinning drive in the same situation. So I'm not going to worry about that in this video, and I don't think the average user needs to worry about that, so we're not going to talk too much about it. Well, the first command here is just for an example, and this one is if you can look in your computer and you can see whether you have an SSD. Maybe somebody just hands you a machine to play with, right? You just have this computer sitting there and you go, oh, I wonder if I have an SSD. So with this command, let's make that just a little bit bigger. You can just replace this X here right there with the drive letter that's in your system. So we're going to try that with SDA. We're going to see what the output looks like for my computer. Well, the output is 0. That means that it is not a rotational drive. This is an SSD. If I rerun that command one more time, and this time we change that to a B, you're going to find out that the output is 1. And that output is telling us that the second drive in this system is a spinning drive. So 0 would equal an SSD, 1 equals a regular spinning hard drive. Now, how do I have this set up in this system? Let's look at LSBlock and talk about that just a little bit, because what I have done is I went out and I bought myself a small capacity SSD, 64 gigabytes, and I am using that SSD, which is SDA, as the system drive in this computer, which means that it holds the actual operating system itself, and it also has a swap partition. Now, before anybody out there starts screaming, you shouldn't put swap on an SSD, stop. This machine has 12 gigabytes of memory in it, and it is probably never going to actually use swap unless I have like 6 virtual machines open. And if I am ever in a situation where I actually do need to use that swap space, I'd like it to be fast, and I don't mind using it on an SSD. Part of the paranoia that you'll read about is people saying, never put a swap partition on an SSD, it'll kill it, it'll wear it out. Yeah, if you have a machine that has 1.5 gigs of memory in it and you're trying to run like the Cinnamon or GNOME desktop on it and it's constantly swapping, that may be true. But if you have a modern machine that has enough memory in it where the swap is not being used constantly, then that's probably not an issue. And even if swap does get used, it's going to be faster. That is one of the advantages of an SSD. You have faster read rates and faster write rates than a standard spinning hard drive. So if you actually use the swap, and I would put the swap on the spinning drive, the machine would really slow down if it was using it. So that's fine with me. So that's how I have this system set up. Now, a lot of people out there with laptops and new desktops and all-in-ones, they probably have one hard drive in it, and that hard drive is an M2 SSD or a SATA SSD, and the whole system, the whole thing's on there. Your personal data, your system, everything is on that drive. And if that's the case, then you have no choice. You have to put your swap on there, because when Linux installs, it likes to have a little bit of swap to play with. Every kernel developer that I have ever read or talked to or heard from has said, yeah, you got to have a little bit of swap, even if it's just a little 2 gigabyte swap file or whatever. In the case of Linux Mint 18.3, it's actually looking for a full-size swap space, which means the size of the memory plus a little bit more. That's how it sets it up automatically, and that's how I set it up. So that's all I'm going to say about swap and SSDs. Don't worry about it. It'll be okay, okay? Let's start getting into how you can check your partition alignment. This is something that, I'm sure a lot of people are now wondering about. It's like, well, is that done properly? Did the installer get it? Did I clone this when I installed this? I don't remember exactly how I did it. So that we just used the Parted tool to figure that out. So the first command that we're going to put in is this one. And if we come back over here, put that in there, and then I'm going to add super user privileges up front. So we have to run it with sudo. And then for our drive, we know that our SSD is A. So let's put that in there. Now it's going to open up the program, put a password in there, and we are now into Parted. So the command that we need to run is the partition check command, which looks like this. Now, N is going to be the number of the partition on that drive, and I happen to know that that is 1, so let's go ahead and make sure that's copied. So I'm going to paste that in here, and we're going to change that in to partition 1 on that drive. And it tells me that it is properly aligned. 1 is properly aligned, so that's good. So to get out of that, just type exit, and that will let you out of where parted. Well, maybe not. Let's see. Maybe it's quit. Yes, it's quit. Okay, good. Glad I figured that out. So that's a quick little check that you can do to make sure that your drive is aligned properly. And if it comes up and says that it's aligned, you are totally good to go. The next thing to talk about is trim. What is trim and how do you deal with it and all this other stuff? Now, here's where you're going to see the most garbage on the internet about SSDs. You're going to have all kinds of different opinions, how to implement this, where to implement this, what to do with it. And I'm going to go along with the Ubuntu developers and how they deal with it, and that's exactly what I'm doing, and this is how we're going to deal with it. So what does the trim command do? It enables an operating system, actually the file system in an operating system like ext4, to notify the SSD of pages that no longer contain valid data. So when you are writing data and then deleting files from a regular hard drive, when the file is deleted, it's not actually erased. What happens is that file becomes unlinked. There's no reference to it in the tables, the thing that the system uses to actually figure out where the data exists on the drive. The data in the data pool is actually still there. So in the case of a spinning drive, that's no big deal. It doesn't care about rewriting over old data that's in the data pool. It makes no difference. With an SSD, rewriting means it has to go through an erase cycle first. Remember, it's called EEPROM, electronically erasable, programmable read-only memory. So it has to be erased first, and then it has to be written to. That's 2 write cycles. So what the trim command actually does is it tells the SSD, this block of data, you don't need to worry about it. You can just write over it, and it takes care of it in one shot. And this makes the performance of the drive stay, as the drive fills up, it gets a little slower because it's trying to figure out where to allocate new data. So if you essentially tell it, well, none of this extra data that's actually erased data makes any difference, then it won't worry about it and it will write faster. So you need to trim the file system on a drive like this once in a great while, or else it may slow down. Now, some people advocate doing this every day. That's not a good idea. It is actually said that trimming an SSD excessively will cause wear to happen faster. It'll accelerate the wear. So what the Ubuntu developers did was they essentially set up a cron job that runs once a week, and it runs the fstrim command automatically in the background without any input from the user. And running it once a week seems to be a nice balance. It takes care of trimming the drive, but it doesn't run it all the time. So some people say set it up daily to do that. I mean, unless you have a great deal of data coming in and out of the drive, you're adding files and deleting files, what's the point? I mean, it's probably not going to be that big a deal. And then the most extreme thing to do is to actually go into the file system table, the fstab file in etc, and then put the discard on the end of that little discard flag on the end of the options there for the fstab entry. You don't have to do any of that stuff. Don't do it. There's also people talking about adding no access time. Access time is there for a reason, and I'm very uncomfortable with going into the file system and telling it, no, don't write the access time. There are certain programs and certain administrative tasks that need that access time. Let it be. Let it do what it needs to do. Now, as far as fstrim is concerned, you can do it manually. It's really quite easy to do, and it's just one quick command, and this is the command right here. So let's get our terminal back, and we will paste that in there, and I'm just going to go ahead and run it so you can see what happens. And it did it very quickly because this is a brand new drive. I have already run this once or twice to get prepared for the video. If there was a whole bunch of stuff that it needed to trim on the drive, then it would have done it and it would have taken some time. So you may find that if you do this like you've never ever done it, that you would it would run longer. But if you're running Ubuntu 16.04 and up, this has already been done once a week. So where is that happening? That is happening with Anacron, which is a subsystem that runs on Ubuntu and Debian and many other distributions of Linux as well, that have a list of scripts that it runs on a daily, weekly, hourly, or monthly basis. So if we want to take a look at the script that actually runs in the background to take care of this, then where we would look is, let's use the less command to be able to read the script, and we're going to look in etc, and then we're going to look under cron.weekly, and then we're going to look for a script called, let's just go ahead and let's just go ahead and go in there. It's not going to do what I need it to do. Instead of doing less, let's cd. This would make probably more sense to do it this way. All right, so let's list the storage. That's it, fstrim. That's the one that we actually need. So if we now look at fstrim, we can take a look at the script itself, and you'll see that it's essentially like one line, and that is fstrim with the all option, and then it just checks to make sure that it ran properly, and it's done. It just dumps it. That's what the true is at the end there. And that's all this little script does. So that will run on a weekly basis in the background, and you'll never have to deal with it, so don't worry about fstrim. And that's pretty much all I have to say about SSDs, gang, in this particular video. Really, there's not much more to talk about. You can go read to your heart's content. The only thing is that I warn you that some of the stuff that you are looking at, it's old, it's outdated, it's paranoid, it's people worrying about frying SSDs prematurely 10 years ago when maybe there was a chance that that could happen. Modern SSDs, especially the higher the capacity of the SSD, the longer it's going to last. The more room it has to work with, the more the electronics in there, the firmware can move that data around from little flash memory chip to flash memory chip and make sure that it's not wearing out the little EPROMs. That is all taken care of in the background, and you don't have to do anything with it. And that's all there is to it. So thank you for watching the video. As always, your feedback is welcome. Please be sure to give EzeeLinux a like on Facebook. Also, check out freedompenguin.com for lots of really cool stories about Linux content from providers such as myself. And check out EzeeLinux.com. That's where it all comes together in the EzeeLinux project. Before I wrap this video up, just as a little aside at the very end, I'm going to show my age because I'm going to tell you a little story. Way back in 1985 or 86, I think it was 85, late 85, my brother bought a computer, and it was a Tandy 1000. And that computer at the time was hot stuff. It was a really good machine. Now, up to that point, I had had a Commodore 64 with a data set on it. That's a cassette drive that you would sit down and type your little programs in that you'd get from your book that you picked up at the bookstore or the magazine, and you would actually type little basic programs, and then you would load them onto this cassette, and that's how you saved your programs. And then my brother comes home, and he's got this computer that not only had two 5 1/4 floppy drives in it, but it also had a 20 megabyte hard drive in it. And at that particular point in time, we didn't think that we would ever come up with anything to fill that 20 megabyte hard drive on. That was also my first experience with MS-DOS, by the way. And so then you fast forward 10 years from there. So we're going from 85, 86 to 95, 96. And now I'm working in a radio station. And at this particular radio station, we installed this automation system. And what was really cool about this automation system was that all of the audio was going to be contained on hard drives, and it was going to be aptX encoded, and it's going to sound really good. And up to that point, we had an automation system that had jukeboxes. They had CD jukeboxes that we would load up, and the automation system would send signals to these CD jukeboxes as to what disc and what track to play, and they were always screwing up, and it was really bad. So we were very excited that we were actually going to be able to take all of our jingles and commercials and liners and promos and all of the music and stick it on a hard drive so that we wouldn't have to fool around with any jukeboxes. And that machine came shipped with a 9 gigabyte hard drive. And at that point in time, this drive was huge. If you could imagine taking 2 regular CD-ROM, DVD-ROM drives, RAM, ROM, those things, and stacking them on top of it. So 2 5 1/4 bay slots. That's how big this hard drive was. And when it ran, it sounded like it was churning butter. It actually shook the counter that it was mounted under, the drive server, the server for this automation system was mounted under this counter. And when that drive was working hard, you could be leaning on the counter with your elbow and you could feel it working. That's how much energy it took to move those heads across all those platters in that 9 gigabyte drive. These days we talk about 3.5-inch hard drives that have 8 terabytes of storage. These are regular spinning drives. And we talk about little desktop 2.5-inch drives that can easily be 2-4 terabytes, something like that. And these are regular spinning drives. And as far as the solid state drives are concerned, well, now they have these little M2 drives that mount directly into the motherboard, and they can have a terabyte of storage on them. And of course they're very expensive, but they are. And they're just these little chips. They look like memory chips. They look like DIMMs. For somebody who's been around computers for as long as I have, the progress of storage is just mind-boggling. The numbers blow my mind. We throw them around all the time. And I just wanted to point that out. I wanted to, at the end of this video, point that out because it's just amazing the storage options there are and how good the solid state storage is these days. So I wanted to say that because in this video I've tried to stress that there's a lot of old information on the web, and if you want to do whatever with your SSD, go ahead. Don't be trapped in it. Have fun with it. It'll probably outlast a regular spinning hard drive at this point. Not that I don't still like spinning hard drives, and I use them for my systems, but at some point I think we're all going to be going to some sort of solid state storage, and it'll probably be better. Thanks for watching once again. We will do it again soon.